Today's lesson is on solving radical equations. We're going to follow a simple three-step process. First of all, you're going to isolate the radical on one side. Sometimes it'll already be on there one side by itself, but sometimes you'll have to work on it. Then we're going to square both sides. That's if it's a square root, but if it's a cube root, you cube both sides and so forth and so on. Next, and most importantly, we're going to check for extraneous solutions. Again, remember, extraneous means that you found them correctly, but they're no good. They just don't solve the original equation. Alrighty, let's see if we can put those steps into action. Alrighty, we see we have a radical, so we need to get it by itself. So we're going to add 1 to both sides. And then we're going to divide both sides by 2. And now the radical is by itself. So the next step says square both sides. So we're going to square both sides. So the square and the square root cancel. By the way, no need for plus or minus or absolute bars, absolute value bars. Okay, so no need for absolute value bars or plus or minus. Not needed at all. So we have x plus 2 equals 16. Subtract 2 from both sides, and now we have x by itself. Last step, check for extraneous solutions. So for our double check, we're going to always go to the original equation, and we're going to substitute 14 in for x, and we're going to see if it's equal. And remember, do not cross the equal sign. So the square root of 16, that's 2 times 4 minus 1, indeed is 7. So this we've double checked and it's a good solution. Okay, let's move on to example 2. Why don't you pause the video and give it a try? You might be able to figure it out. Okay, we already have the radical isolated. So I'm going to square both sides. We have 2x plus 7 equals. Remember when you square a binomial, you cannot distribute the square to both terms because of the minus sign. So 2x plus 7. And if we first outer, inner, last, and combine like terms. Now, this is a quadratic equation. And so we have to think back to our different techniques for solving a quadratic equation, meaning the highest exponent is 2. We want to put everything on one side. So we get x squared minus 10x plus 9 equals 0. And I'm going to try a diamond. Remember, we need 2 numbers that multiply to 9, but add up to negative 10. So negative 1, negative 9 works. And we can solve by using the zero product property. So we see that x equals 1 or x equals 9. At this point, we definitely have to double check for extraneous solutions. We're going to plug 1 in to the original equation. And see if it's equal. And we're plugging 1 in for all the x's. And again, don't cross. So the square root of 2 plus 7, that's radical 9, which is 3. This is negative 3. Uh-oh, that is not equal. So that means 1 is indeed extraneous. We're going to check for 9. And let me caution you, sometimes neither works. So I'm plugging 9 in. So I'm looking at the square root of 18 plus 7. Radical 25 is 5. And that does equal 5. So that is a good solution. I'd like for you to think back. Look at this original equation. What's the degree? Remember, the degree tells you how many solutions an equation should have. Well, you have the radical, which is exponent like 1/2. Then we have an x that's exponent 1. And indeed, 1 is higher and we had one solution. But if you look back here to example 1, the degree, I guess you could say, is 1/2. You can't very well have a half of a solution. So they're just very inconsistent, very temperamental. And as you learn more about domain and range, you'll learn why sometimes you have extraneous solutions. Alrighty, at this point, we have a radical on both sides. We can't very well isolate both radicals at the same time, so you just isolate one of them. And the one on the right is already isolated, so I'm going to square both sides. Now you have to do this very carefully. The right side is easy, and we get 7 minus x. Over here, we're going to have to FOIL this. And you want to, like I said, you want to be very careful. So we're going to first. Now, when we do first, that squares it, and we just get x plus 6. We're going to do outer, which gives us 1. And then when we do inner, we get another 1. Now, these are indeed like terms. And then last, we get 1 times 1 is 1. Now, the good news here is the like terms. So we only add the coefficients. So that gives me 2. And now I'm simply going to combine like terms and go back to step 1 and isolate the radical. So let's see. I'm going to subtract x from both sides. That's 6 plus 1 is 7. So I'm going to subtract 7 from both sides. I have, that's gone. That's going to be gone with that. And I'm left with 2 times the square root of x plus 6. That's gone as well. And a negative 2x. Oh, wait a minute. I think I did something funny there. Oh, no, I didn't. That should be fine. Okay, now I'm going to divide both sides by 2. And I get x, the square root of x plus 6 equals negative x. Now I'm going to square both sides now that I've isolated the radical again. So notice when you have a radical on both sides, you usually have to do the process twice. Now the square and the square root cancel, no absolute value. And when you square a negative sign, it goes away. Now I'm going to put everything on one side. I often like to go to the side where the x squared is. So that's gone, that's gone. I have x squared minus x minus 6 equals 0. Again, I have a quadratic equation, and you'll see that that happens a lot with radicals. And so now I'm going to do 2 and 3, negative on the 3. And so I have x plus 2, x minus 3. And let's see, negative 2, positive 3. Don't forget the last step, and that's checking for extraneous solutions. You always double check in the original equation. You have to double check the original equation. So I have negative 2 here, plus 6, plus 1. Does that indeed equal So now I'm looking at the square root of 4 is 2, plus 1 is 3. Does that equal this side? That's 7 plus 2, radical 9. Yes. So that side is equal. Now I'm going to check to see. So that one's good. And now I'm going to check 3. And if I plug that in, does that equal 7 minus 3? So I get the square root of 9 plus 1. 3 plus 1 is 4. And this is the square root of 4 is 2. That's not at all equivalent. So my only solution is x equals negative 2. Now, today I only demonstrated squares and square roots. So we only did square roots. But I'd like for you to know that it works the same. And as a matter of fact, if you have cube roots, like say you were trying to do something like this, you just cube both sides. And it's just that easy. Okay? As well, and of course you want to isolate first. Also, let's say you have something like the 2/3 power equals a certain number. Then all you have to do is make the exponent 1. However, I like to caution you. See, that turns into just x over here. But I'd like to caution you that you might want to put it in radical form first. For me, if I have x to the 2/3 power equals 16, for me it'd be better to rewrite that as the cube root of x squared. For me, that just works a little bit better. So I would start off doing the square root and then the cube root of x, and that would be 4, and then cube both sides. I'm just a little more comfortable with the radical notation. But notice here, it works just the same. You can take the square root of 16 and cube it, and you're going to notice that it works out just the same.